Hello, mathletes. Here we are looking at rational functions. So when we think about rational functions, we should be considering functions that have x's in the numerator and in the denominator. So we're saying like p of x here, it's just saying it's going to be some function p of x and q of x. They need to be polynomials. So we don't want anything with negative exponents necessarily or fractional exponents, but those polynomials, remember, have integer exponents in the numerator and denominator. Okay. The most basic one is the inverse variation function, where you have f of x equals some constant a over x. So you might have a function like 1 over x or 2 over x or 3 over x. And so when we look at these functions, they have unique graphs. The graphs, you should note, have vertical asymptotes and horizontal asymptotes. Okay. And so those are the rational functions that we will be looking at today. Our main goal is to be able to multiply and divide them today. So first, when we're thinking about rational expressions, we should remember when we're simplifying them, okay, we're looking for common terms. So here in this example, it's c, that they are factorable, and we're going to divide out that common factor, because anything divided by itself is 1. And so 1 times a over b is a over b. So you're going to divide out that common factor. It might look like a variable here with the c, or sometimes it might be a constant. So if we're simplifying 15 over 65, they both have a 5 in common. They're left with 3 over 13. We can do it with variables. So if we have 4 times the quantity x plus 3 over x plus 3 times x plus 3, this goes to 1. And then we're just left with 1 times 4 over x plus 3, which simplifies to that. So let's look at an example here. First, I want to talk about some very common mistakes. So remember, we can only divide out factors. So the common mistake I see with Algebra 2 students is that if we're trying to simplify this fraction here, okay, well, let's know what that value is equal to without simplification. So 1 plus 1 is 2, 2 plus 1 is 3. So that's a 2/3 fraction. So anything that we simplify to should have the equivalent c of 2 over 3. It could be 6 over 9, it could be 10 over 15, but it should be equivalent to that. So what students will have to do is they'll recognize that there's a 1 here and a 1 here, and they'll try and cancel those out. The problem is these addition signs, whether it's addition or subtraction, we don't want to cancel those out. Because if we cancel those out, all of a sudden we are trying to say that 2/3 is equal to 1/2, and we know that's not the case. Okay, so careful with addition and subtraction signs with simplification. I'll see that too with these types of values with exponents. This is more common mistake with or not exponents, but variables. And students will see an x, and they just want to go ahead and simplify that out. But that is not equal to 1 over 2. That fraction is equal to 1 plus x over 2 plus x. There is no common factors between those two binomials, so that is simplified form. Okay, so make sure as you're simplifying things, you break things down into factors, and you only simplify things that are being multiplied. Okay, so as we're simplifying this, we want to break it into its factors. So now we have to factor our quadratics. Okay, well, there's an a value of 1 here. So I'm just looking things that multiplied in -12 and add to -4. So I'm going to get 6 and 2. So x minus 6, because this 4 is negative, I'm going to get x plus 2. If you remembered, you still need to use your diamond method and say, all right, -12 and -4. Things that multiplied in -12 and add to -4 are -6 and 2. Okay, so as I'm factoring quadratics, I might not always show these here in this unit because we have covered factoring quite extensively. So x squared minus 4 is a difference of squared, so this should be x minus 2 and x plus 2. Okay, so be very careful with your parentheses. That helps identify your factors. So only things that are in parentheses that are equivalent can be canceled out. So notice I get x plus 2 over x plus 2. That is just 1. Okay, so my answer is what's remaining. So my simplified form of this is x minus 6 over x minus 2. Okay. In our next example, okay, or concept, we want to make sure that as we're multiplying fractions, remember, multiplying is just top across the top. A times C is AC, and B times D is BD. So we just multiply the top by the top, bottom by the bottom. What we're going to see a lot of is when we're simplifying with variables, okay, we want to make sure we collect our like terms. So as I'm multiplying, I'm going to look for like terms. So 5 and 3 is going to go to 30. X squared and x goes to x cubed. No y and y cubed goes to y cubed. Denominator 2, 10 is 20. X, no x is just 1x. X squared times, or I'm sorry, y squared times y is y cubed. So using our power properties, remember, if you do x squared, or let's keep it generalized, xa times xb, you add those exponents. That's a plus b. Okay. So as we have it in here, we got to make sure we simplify and look for common factors. Well, 30 and 20 have factors of 10 out, so we get 3 and 2. X cubed divided by x is just left with x squared. Y cubed divided by y cubed, well, that is a form of 1, so that cancels out, and we are left with 3 times x squared over 2. Your values that it can't be equal to are in reference to making sure your domain here is consistent. So since we had x's and y's in the denominator, we know we cannot divide by 0. And if x is 0 or y is 0, we'd get that. So that's where these exclusions come from. Okay, so if I'm going to find the product, okay, I'm going to first just look at my numerator. And so 8 and 7 is 56. X cubed, x to the 4th is x to the 7th. Y times y cubed is y to the 4th. Now my denominator. 2 and 4 is 8. X and no x is just 1x. Y squared and y is y cubed. Okay, so now that I've done that, I want to look and simplify between terms. Well, 56 divided by 8 is 7. X to the 7th divided by x is just x to the 6th. And y to the 4th divided by y cubed is just y to the 1st. And we're just left, everything canceled out, so we are over 1, which we know we don't have to write that dividing by 1. And we don't have to write powers to the power of 1, so this is 7x to the 6th times y. Okay. So here, again, finding our product, we're going to want to make sure we factor things out so that things will simplify out. Okay, so I'm going to break things down into factors. So 3x minus 3x squared, well, they both have a 3 and an x involved. So if I factor that out, I'm left with 1 minus x. Okay, my denominator here, things that multiply to negative 5 and add to 4. So I'm going to be x plus 5 and x minus 1. Okay, on my second term, over here, again, factor them out. Things that multiply to negative 20 and add to 1. So I'm going to get 5 and 4. 5's positive because the 1's positive. So x plus 5 and x minus 4. Okay, over, well, 3x is already broken down for us. Okay. So one thing we want to look and be note to is how similar these two are, but they're not equivalent. Okay, so notice it's 1 minus x and x minus 1. Those are inherently different because we get different values. But notice if we ever see where we're just off by our sign and they're just interchange values, so it's the same sign but these two are switched, notice that this value, okay, if I factor out a negative 1, I'm left with negative 1 plus x. You can check your work by distributing negative 1 through, and sure enough, you'd get back to that term. Well, now we have an addition problem, and addition's commutative, so 2 plus 3 is the same thing as 3 plus 2, so I can switch the order of these, and I get negative 1 x plus a negative 1, or x minus 1. Well, now I have something that looks similar to that. So I'm going to integrate that into this problem. So I get 3x, and I factored out a negative 1, but now this is an x minus 1 term. And I'm just going to write these all together because we're all multiplying all these terms together. We don't necessarily have to, because one way to kind of self-check your work is to make sure that things are canceling out. The problems that you're going to get at Algebra 2 level quite often will have lots of things that will cancel out. So notice I have a 3x and a 3x, an x minus 1 and an x minus 1, an x plus 5 and an x plus 5. So what I'm really left with is that negative 1 times x minus 4 over 1, but I don't need to write that. And when I distribute that negative 1, I'm going to get negative x plus 4 as my final answer. Notice how simplified that is. Lots of things cancel out. Okay. So as we're finding our products here, notice that a lot of it is coming back to practicing our factoring. It's a key tool that we need to be able to use from Algebra 2. So x cubed minus 27, well, that's a difference of cubes. So if you remember our sum and difference of cubes when factoring, we're going to have to utilize this. Okay. For our example, our a is x, so it's x cubed. Well, what is cubed that is 27? Well, that's 3. So our b here is 3. So now as I replace this, I'm going to get x minus 3, x squared, a times b, so that's just plus 3x. Remember, a is equal to x in this scenario, and b is equal to 3. Okay, and then b squared is 9, so we get plus 9. Okay. Notice there's often in Algebra 2, we're going to see things that have common factors. So if you're ever struggling with factoring, look what other factors are in the numerator if you're working with something in the denominator or vice versa. And that can be a good key to what will it factor to, because you're kind of anticipating a lot of things will cancel out with the preconceived problems that you're going to be given. So now I can bring this back to factoring. So x plus 2 I'm going to put in parentheses. Okay. Numerator, so this is like over 1. So this is x squared plus 3x plus 9. Okay. All over. Well, we know x cubed can be factored into this, or x cubed minus 27. So we get x minus 3. X squared plus 3x plus 9. Okay. These cancel out, so we are just left with two binomials, x plus 2 on the numerator and x minus 3 on the denominator. Okay, remember, do not try and cancel out these x's because there's an addition and subtraction sign there. This is one term and this is one term. Okay, second part of our lesson goal is dividing rational expressions. So if you, when you first learned about dividing in fractions, you might remember some catchy slogans like keep, change, flip, or copy, dot, flip. That division of something, dividing of C over D, is the same thing as multiplying by its reciprocal. So then we flip our fraction. So that's keep, change, flip. Okay, as I taught 7th grade, we watched some vocabulary about keep, change, flip when you're dividing fractions, if that helps remind yourself. So in an example that we'd see in an Algebra 2 level dealing with variables, okay, so if we're dividing out two rational expressions, okay, notice we're just going to change that division to multiplication. What was our denominator becomes our numerator, and our denominator becomes our denominator. We reciprocated that fraction, or we flipped it. And then we do the same process as we would do if we were multiplying out fractions. Here nothing cancels out, so we just have 7 times the quantity 2x minus 3, and the quantity x plus 1 times the quantity x plus 2. And that's as simplified as we are going to get there. So let's look at our examples. Okay, so we want to find the quotient here. So I'm going to keep the first fraction, change it to multiplication, and flip my second fraction. Now I'm going to factor everything out, so I get 7x. I just write it as one fraction now and include lots of parentheses where needed. So 30 and 11. So I'm thinking of 6 and 5. They're both going to be negative, so I get x minus 6 and x minus 5. My numerator, my denominator, 2x minus 10. 2 can factor out, and I'm left with x minus 5. Oh, that looks like something up there. Coincidence? I think not. X squared minus 6x. Factor out your x. It's actually going to factor out to the right because I've already put my binomial parentheses there. When I factor in an x, I'm left with x minus 6. So notice, x minus 6 quantity cancels with x minus 6. X minus 5 cancels with x minus 5. So as I multiply across here, I'm going to get, oh, I missed one. X and x cancel out, and I'm just left with the constant 7 over 2. Okay, so that's the quotient of those two. Our final example in notes here today. So if you're dividing by something and it doesn't have a fraction, remember it's just over 1. So 6x squared plus x minus 15, that pesky a value is not 1, so I'm going to break it down a little bit here and do my factoring to the left. So a times c is negative 90, and I got positive 1. So 9 and 10, and 1 has to be negative, and that's going to be negative 9. So if I break out 6x squared minus 9x plus 10x minus 15. This is one reason why it's so crucial that you're skilled at factoring, because it comes back in all sorts of different problems. Okay, so then from here, I'm going to take the greatest common factor of the first two. So that's a 3 and an x, and I'm left with x, or 2x. 3x times 2x is 6x squared. 3x times what is minus 9x, so that's minus 3. My second two terms I look at, 10x minus 15. Well, there's a 5 involved, so I'm going to factor out a plus 5. And I'm left with 2x minus 3. These two terms are the same, so I can factor that out, and I know I'm on the right track. And I'm left with 3x plus 5. Okay, so now I can use that, and that's going to be my numerator factored out, and I'm 2x minus 3 and 3x plus 5 over 4x squared. It's already broken down. And now, because I'm changing this to multiplication, I have to flip this fraction. So this is 1 over, and I'm going to factor this out, plus a common x, my GCF. So x times 3x plus 5. Maybe I should use a dot here not to confuse my x's and multiplication signs. And I'm going to look for common terms. 3x plus 5, 3x plus 5. Okay, and that's it. So I just need to multiply across. So top times the top is 2x minus 1 times 1. It's just 2x, misspoke there, but 2x minus 3 over 4x squared times x. So I'm going to see that this is 4x cubed. Okay, that's going to be as simplified as we can get. That concludes our notes on multiplying and dividing rational functions.